Hello, welcome. 7.4. Graphing using slope-intercept form and point-slope form is what we're going to be talking about today. So sorry that I couldn't be in class last night, but let's get started. Let's do some more lines. All right. What is slope-intercept form? Well, when we talk about slope-intercept form, we're talking about equations of lines, and an equation of a line is something that relates two variables x and y, and we can visualize that with a graph. Slope-intercept form is one form of writing an equation of lines. So this is y equals mx plus b. Okay, and in this, m represents my slope, the slope of the line, the steepness of the line. B is my y-intercept. This is the y-intercept. Okay, B is the y-intercept. The y-intercept, well, that is where the graph, the line crosses the y-axis. And it is at the point, 0, B. Remember the y-intercept is a point. It crosses the axis at point 0, B, somewhere along the y-axis, the vertical axis. So if I gave you a question something like, find the slope and y-intercept of this equation, y equals 1/2 x minus 2, I would just look, whatever number is kind of attached to the x is my slope, so that's my m. So I would say my slope is 1/2. And my y-intercept, well, since this is a minus 2, this is my y-intercept right here. Y-intercept is at -2. Now, but remember, the y-intercept is a point, so the point is 0, -2. And I'm not sure why this stupid screen is allow. Oh, because I took a picture of it. Oh, sorry, I ruined everything. But so that's how I'd find the slope and the y-intercept given an equation that's already in slope-intercept form. Now let's look at an example where it's not in slope-intercept form. So let's look at the next example here. Wow. Okay. All right, find the slope and y-intercept of an equation that is not in slope-intercept form. Well, the first thing that I have to do is put this thing in slope-intercept form. So let's do that first. Remember, I'm looking for y equals mx plus b. In other words, got to get the y by itself. I want just the y on the left, all the other junk on the right. Okay, so the first thing I'm going to do is add 3x to both sides. That should give me 4y equals 8 plus 3x. Okay. Now, divide everything by 4. Both sides divided by 4. Okay, well, y then equals, now I'm going to break this fraction up into two parts because y equals mx plus b is not kind of one expression divided by some number. It's two terms, two individual terms. So we could rewrite this as 8 over 4 plus 3 over 4 times x. Could have written 3x over 4. 3 over 4 times x is the same thing. Okay, so this is y equals 2 plus 3/4 x. Now that's slope-intercept form, and that's pretty good. But and on a test or whatever, this would be fine. But this is proper slope-intercept form. So, but like I said, if you wrote the first thing on the test, that would be okay. Okay, so y equals 3/4 x plus 2 is in slope-intercept form. Notice the similarities here. In fact, we could even find the slope. The slope, oh, that's what we were asked to do, sorry. The slope then is right here, right? 3/4. And then the y-intercept is the point 0. Whoa, I guess I got more room than I thought. Is the point 0, 2, right? Because this is my y-intercept right there. So the y-intercept is 0, 2. The slope is 3/4. Remember, you can always pause these videos, watch them again, or whatever. So if I'm moving too fast, please pause and copy down whatever I wrote there. All right, let's actually graph an equation in slope-intercept form. So the first thing that we need to do to graph in slope-intercept form is put it in slope-intercept form if it isn't already. This example here is already in slope-intercept form, so that's fine. Next, plot the y-intercept. Well, first, let's write down what we know about this graph, okay? We know that the slope is, right here, is 3, okay? We might even write that as 3 over 1 just to help us when we graph. The y-intercept is at 0, -2, okay? Now, I can't graph the slope without graphing the point. We learned that in the section that talked about slope. So I've got to graph this point 0, -2 first. That's my starting point, the y-intercept. Now, using my slope, I'm going to graph the rest. And remember that if I have a slope of 3 over 1, this implies that I'm going to go up 3 and right 1 unit. Okay, up 3, right 1. So from this point, I'm going to go up 1, 2, 3, and I'm going to go right 1 unit. And connect the dots. Now your book says, hey, find 2 points. Find 2 more points than just the y-intercept. I don't know why, so don't worry about it. Okay, find 2 points, connect the dots. That's your line. Notice that we've got the arrowheads here indicating that the line goes on forever. Okay, well, that's an example where we're given something in slope-intercept form. Now let's look at something where it's not given to us as kind of nice as slope-intercept form. We might have to put it in slope-intercept form. Okay. All right, graph x minus 4y equals 8. Well, remember, slope-intercept form, the y has to be by itself. So I'm going to subtract x from both sides, minus x, and I'm going to write this as negative 4y equals 8 minus x. Okay. Now, last step, divide everything by negative 4. I'm going to get y alone. Right? So this is going to be y equals negative 2 plus negative divided by a negative will make it a positive plus 1 over 4x. Okay, so negative 2 plus 1 over 4x. Right? Because remember that there's a 1 out here that we don't usually write. Okay, so let's graph this thing. First thing I do is graph the y-intercept. Well, my y-intercept is at 0, -2, and my slope is 1 over 4. Remember, 1 over 4 implies up 1 and right 4 units. Okay, so that's my slope of 1 over 4. All right, so plot the y-intercept first. That's at 0, -2. My slope is 1 over 4, so I'm going to go up 1 unit, and then I'm going to go over 1, 2, 3, 4 units, and connect the dots. Okay, and that's how I graph the line. Now, if it had been like negative 1 over 4, I would have gone down 1 and right 4, as opposed to up 1 and right 4. Okay, so hopefully we kind of figured that out from the last section on slope, but if not, it's a quick reminder. Okay, let's go to the next slide. Okay, now what if we wanted to find the equation of a line given the graph of the line? Okay, so first thing we're going to have to do is find the slope and the y-intercept. If I find the slope and y-intercept, remember that y equals mx plus b. Not sure where to write it here. Y equals mx plus b. That's what I'm going for. It's got 2 pieces, the m, the slope, b, the y-intercept. So let's first find the y-intercept. Now the scale on the y-axis is kind of goofy, but I think that the y-intercept, this point here, is at 0, 2. So that's the y-intercept. Now we can find the slope in a number of ways. One way is to pick 2 points on the graph and use the slope formula to find the slope between them. My personal favorite way when I'm given the graph is to pick 2 easy points, so maybe 0, 2, and it looks like this is a pretty easy point right here. Oops, maybe not. Actually, because the scale is kind of goofy, let's pick this point here, because I think that this is -1, this is -2. So I think this point is -1, I'm sorry, 2, -1. Okay. So now, a couple ways I can do this. I can count my rise and then my run, or I can use the slope formula. I think I'm going to use the slope formula, just so we get a little bit of practice with that. So the slope of this line is going to be, let's see, -1 minus 2 divided by 2 minus 0. Okay, so that's going to be, let's see, negative 3 divided by 2. So my slope is negative 3 over 2. My y-intercept is at 0, 2. So I think my equation of the line, change colors here, so my final answer is y equals my slope, negative 3 over 2, times x, plus my y-intercept, so plus 2. Okay, that's my final answer. So in other words, to get from my y-intercept to this point, I go down 3 units and over 2 units, and right 2 units. Okay. All right, let's look at another one. What if I wanted to see if two lines were parallel or perpendicular? Well, to do this, I need to put this in slope-intercept form first. So do that first. Put this stuff in slope-intercept form, okay? Well, I'm going to subtract 3x from both sides. So I'll get negative 2y equals 7 minus 3x. That's a really good 3. Okay? Divide by negative 2. This all goes away on the left. I get y equals 7 over negative 7 over 2. Okay? And then, once again, I've got this negative divided by a negative. Okay, so this is going to be a positive 3 over 2x. Okay, so that's my first equation in slope-intercept form. Notice that in fact, we can even put it in proper slope-intercept form. Y equals 3 over 2x minus 7 over 2. I just changed the positions here. But that is slope-intercept form. Slope is 3 over 2 then. Okay. Let's put this next one in slope-intercept form also. So I better draw a line here. So first thing I'm going to do is subtract 4x from both sides. So I'll get 6y equals 6 minus 4x. Divide by 6, divide by 6. Alright, so then I'm going to get y equals 6 over 6, I think is just 1, minus 4 over 6x. Okay. Well, let's simplify that fraction. Y equals 1 minus, I think this is 2 over 3x. Okay. And now, I've got them both in slope-intercept form. Okay, and I guess we can write this once again. This is actually negative 2/3 x plus 1, so we'll write it in proper slope-intercept form. But I've got them both in slope-intercept form. Notice that my slope on the left, m in this one, equals 3 over 2. And then m in this other one, over here in blue, is m equals negative 2 over 3. Last section we learned about the different types of slopes, and when slopes are perpendicular, they're opposite reciprocals. So in my example on the left, I've got m equals 3 over 2. The opposite reciprocal of that is 2 over 3, the negative of it. In other words, negative 2 over 3. So these are perpendicular lines. Okay, so these